A spontaneous video. This wasn't actually planned, it's just what's going to happen. This is the light fitting that was above my computer, and the fluorescent tube in it started dipping and flickering. And what's actually happened here is that the end of the fluorescent tube has failed. It started sputtering. And that, let me turn this the correct way to get the tube out. There we go, that's the tube out now. You can see it's darkened, and what's actually happened there is that inside there's a heated cathode, and it's got what's called a thermionic emissive coating. Is that right? Thermionic emissive coating on it. Let's just say an emissive coating. And the idea is that when it's hot, it lowers the voltage drop across the end of the tube, and it means you can operate these long fluorescent tubes on a fairly low voltage. But in this case, that end electrode is burned up a bit, and the voltage has risen to the point it's actually melted the plastic a little bit here. It tends to get quite hot when that happens. And the tube has started failing. It started dipping and flickering because the voltage across it wasn't able to sustain normal operation. So I'll put that tube out of the way. I'll probably smash it at some point accidentally. The reflector, this isn't the original reflector. I've swapped reflectors with another light, because it was actually distorted with the heat as well in the same area, and it is from the tube. So I should put that out of the way as well. And I was thinking, this light has a connector at the end. I want to just keep the standard connector that's already up there. Could I put LED tape along this? Because it's actually too bright as it is at the moment. And all I need is low-level illumination to see the keyboard on the laptop. So I was thinking of sticking in some LED tape, but I'd need to provide a 240 volt to 12 volt type power supply. And one of the things that came to mind, if it will fit in, what have I got up here? I've got, oh, there's one. I've got these tiny little drivers that are actually current limited supplies, but they're designed for 3 to 12 volts at 300 milliamps. Do I have another one? Yeah, so this is a 2 to 12 volt 300 milliamps, so a current limited supply that also tends to cap the voltage. And I was wondering if it would actually work with a piece of this LED tape, and I've chosen the 50/50 tape because it draws a sort of higher current. You may hear a slight humming in the background when I'm talking. It's the transformer in the soldering station. So the first thing I want to try and do then is see if this little power supply, because the power supply itself is tiny, and it should hopefully fit inside this light. These are the ones they often fit in the bases of GU10 type lamps, the 3-watt GU10 type lamps. So I reckon this should fit inside here. Looks like it's going to fit inside there. And if it does, then I can rewire this fitting to actually drive the LED tape. So first thing I'm going to do is I'm going to connect it to this tape and see what's going to happen. So this is the waterproof tape. I'd rather it hadn't been the waterproof tape, because in this application I prefer the more flexible nature of the non-waterproof stuff, because it tends to stick better. But it also makes it a lot easier to terminate onto. But at the moment, I've taken a knife and I've very carefully slit up the end to try and separate the waterproof coating from the circuit board material. It's always quite hard stripping these things. And now I'm going to take a pair of snips and cut that off. I could have zoomed in, I could have shown you more detail there. I didn't. Most remiss of me. Let's move this out of the way. I noticed the exposure is just a bit ferocious. No, that's actually worse. Let's nudge over to the exposure detection point. Oh, it's not detecting it. Where am I exposing at the moment? Well, that'll do. So let's put that out of the way. And I shall connect this little power supply onto this tape, just experimentally. So I'll tin these wires and solder it on, and then we'll power it up and see what sort of voltage is across the tape. So I need solder. I did have solder. I've misplaced the solder. I do this quite a lot. The bench is very cluttered. You'd be just mortified. It's like any busy bench. Any sort of, if you look at the YouTubers that are always really just building stuff, their benches are always a real mess, because it's just endless projects. And stuff gets left in the bench, so it's just they end up cluttered. It's normal. So if your bench is cluttered, that's fine. It's just how it is. It means you're being productive. If it's immaculately clean, then you've obviously not got much going on. My apologies if I've just offended someone by saying their bench is too immaculately clean. Then again, there are those of you who work at the kitchen table, which is the classic place to work because it's a nice clear area. And if you do that, then it's useful to have a tray that you can put a project on and just move the tray in and out as needed. Right, let's get the quick test in and slam those wires in. Let's get my meter in readiness. Fluke at the moment, my original Fluke. When I went out self-employed, I'd used one of these Fluke meters with EJ Steel & Co electrical engineers, and it was like, it was iconic to me at the time. And it was really, really expensive, but I thought, you know, if I'm going self-employed now, I should really get the best of the best. So I got one of these. And it's, you know, that was decades ago. It's a great meter. It never got taken too much out in jobs though, because I ended up keeping it more or less as a bench meter because I didn't want it stolen, because such meters are very desirable. So let's keep in mind this is going to be live. Let's get this tape down. This is where the tape is going to swamp out with the light. Let's see if this just goes bang actually. It's lit. Good. Let's measure the voltage across that, because that will give me an indication. If it's less than 12 volts, it's ideal. It's 11.41. That is absolutely perfect. I wonder what the current is. Best way to measure the current is to put something in series. What can I do here? I know what I can do. Tell you what, I'm going to desolder that wire. And I'm going to bring in the wee cheapy meter because it's got the croc clips on it. Or alligator clips if you prefer. I'm going to turn it to the 10 amp setting, which means I'm going to have to change that over to there. I'm just looking at the fact this lead has kind of snapped here, which reminds me, if you look at John Ward's channel, I think he's featured it. There's been a recall on some of the Fluke test lamps because they've found that the leads are breaking at the point they enter the case or onto the circuit board. The notable thing being here, if you think that Fluke seem to have an awful lot of recalls, it's simply because they actually care enough to do the recalls. Being sort of high profile name, they have to protect their image. So let's, this is 10 amps DC, let's see what current is flowing. 260 milliamps, that's kind of less than I was expecting. I wonder what's top bottomed out first. I wonder if that's what this current limiting power supply is limiting current at, or if it's the upper voltage, open circuit voltage has been met. There's one way to find that out. I could just make it completely open circuit and measure the voltage across that and see if it goes much more above 12 volts. Oh, it's gone up to 21 volts open circuit. That's exciting. Right, I shall disconnect that. It is a current limited supply. The open circuit voltage tends to float. I'll change the leads back to the normal settings. Always a good idea with your meter. One of the things that made me like this meter so much was because it's got a really tough rubber case. They gave it a specification to be dropped from a great height. When you look inside this, it looks a bit primitive because it is an old meter. If you searched for RS components stock 203489, it would have been discontinued a long time ago. For reference, the serial number on it is 537-61374. And this is an original American-made meter. All the Fluke meters these days, I think the standard meters are all made in China now. Which makes sense because it's just the way things have gone, isn't it? Right, I'm happy with that. So what I'm going to do now, I'm going to put this power supply out of the way. I'm going to open that light fitting and explore the inside. So I'll desolder this other connection. I shall bring this up and take a look inside. Now, this has an incoming plug end, and it's got an outgoing socket end, but I don't need the socket end because it's just going to be used fed from one end, which might make things a bit simpler. But let's try and open this up. And I can see it's got these little tabs down here. Hopefully this isn't going to be too destructive. It's chewing the plastic up. It's already got a bit destructive. Oh, that's an end off. That's good. So what we got here, is that the... Does this switch have to come out? This is me probably bursting it. I'll try not to burst it. That looks kind of okay. Oh, it's a secondary. Is that a secondary sleeve it's got in there then? For secondary insulation? Not really sure. That's strange. So I don't need this end, so let's just cut all the wires. I don't need the wires into this end cap either. So let's chop them. I'm guessing that when they're constructing this, they will just ultimately just terminate these wires into one of these end caps last. Oh, actually, I'm seeing there were two wires looping there, so that might have been looping back. I've probably screwed things up badly. Right, that's not really much a surprise for me. Ooh, okay. There's a little end cap. It's a fairly standard looking tube connector with the rotating contacts at the end. Interesting. Let's get this off. So that is, I tell you what, that looks like just a little reinforcing bit in the end to sandwich this into, by the look of it. Not sure. Almost like just a strengthener. I'm kind of intrigued what's in here now. So let's cut some wires. This time I'm going to cut these wires. I don't need these ones. I do need these ones. Shame they don't come out. Maybe they do come out. They look like those pins that are pushed in and then snap in, but I don't know if they're sort of, maybe they're actually heat welded in. Oh, they've soldered the connections on. Maybe I should rewire this completely by pulling that back with my schnips and desoldering it. That sounds like a good idea. It's probably a terrible idea. That's okay. I do want to keep the switch intact. I just want to empty this thing out and see what's inside. I want to see the little driver for the tube. So let's, yeah, a couple of wires. Let's drop them on the floor. So inside this somewhere is that driver, and it's going to kind of be filled by the fact that I've got this switch in here. Oh, there's the driver. I should be a bit more careful because I think it was turned on fairly recently. Oh, that's right, okay. I think we'll have to rewire the switch as well. There we go. That's made everything easier. Here is the driver. Okay. This is a fairly classic. Oh, it's actually looks fairly decent quality. Let's discharge that big capacitor there. That's the spicy one. The others will give me a bang, but not quite as much as that one. If it holds a charge. Nope, that's not holding a charge. Finger test, that's good. What I've got here, we've got the fuse coming in. We've got the class Y suppression capacitor. We've got a common mode suppression choke, a bit more filtering. We've got the bridge rectifier with the diodes scattered everywhere. They've just tried to fit this in. And then a smoothing capacitor, 400 volt, 3.3 microfarad. And then this very common arrangement here, which consists of two transistors. And this is the inductor that's being used to limit the current through the tubes. We've got the feedback toroid. If you ever take apart a compact fluorescent lamp, because this is basically a compact fluorescent lamp driver, but just driving the longer tube. If you take one of them apart, you'll find that it's got the little toroid in here, great for making jewel thieves. But the interesting thing about this is that the toroid is driving, it's got three windings on it. It's a winding in series with the tube and the inductor, and it's got two other windings that drive the transistors. And it's a very simple arrangement. It's triggered initially when you turn it on by this little diac here, when the voltage reaches a certain threshold, and then because of the arrangement of diodes, I'll cover this in a separate video one day because it's an interesting circuit. It's absolutely minimal they could do. And it triggers it, and then it basically starts the circuit oscillating with these transistors pushing and pulling, coupled directly with their bases being driven directly from these windings. It's very clever. Other things worthy of note: there are capacitors in series to limit the current through them, and also this device down here is a PTC thermistor, which is probably being used as a soft start. Initially, when you turn it on, it will pass a higher current through the heated cathodes at the end to heat them up, and then once it's been running for a while, it will go high resistance and it will lower the current through them. Looks like a classic circuit. Right, I'm going to completely rewire this, I think, then. So I will probably put the circuitry down at this end. Is this going to fit in? This is going to be a real project killer if this doesn't fit in. It is going to fit in. So I'm going to make a hole at this end with a drill. Then I'm going to rewire this. I'm going to basically have the live and neutral come in. The neutral will go straight to that power supply, but the live will go up and it will go through this switch at this end, and then come back down to that power supply. So I'm just going to pause momentarily while I get all the wiring. I won't pause. I'll just keep going. That's the best thing. Then you don't miss any of what happens here. That means that you guys get the choice of whether you watch it or you skip. So let's find the wire. It's quite thin wire. I'm not really bothered about that. It's not a very high current circuit. So I'm going to get a drill. I'm going to roughly place this in at the end here. So it's going to go in there. I'll drill the hole fairly close up to here. Okie dokie. Now I could feed it from the other end, couldn't I? I could actually put the clip on and then the feed would come down via the switch to the other end. That would make it much less cluttered. And then that means at the other end it would just be like the brown and blue wire. That sounds like a good idea. So I shall start then. Can you tell I'm making this up as I go along? To start off then, I'm going to get the wires onto the plug end. This end is not needed. This is the socket end, so I'll just cut them flush at the end. Misusing these snips as always. I shall get the plug end, which I've misplaced. There it is. And I shall also put a bit of heat shrink over those, just as an extra precaution. So I want the neutral running up from one end to the other. I shall cut them a little bit longer. There's no harm in having a bit of extra length. I'll use my strippers here. People often ask about these strippers. They're Unior strippers. It's just the ones I got. I think they came from Bill's Tool Store in Glasgow. This is a non-polarised, it is actually a polarised connector. Not too bothered. It's not going to be that critical. Technically speaking, it is slightly critical. You're supposed to put the switch in the live, but it doesn't really matter because it would just be unplugged completely every time. So I'm going to reflow some solder onto these. I'm going to tin this wire. This is where putting the heat shrink on beforehand would probably have been a good idea, but not to worry, I didn't. I'm guessing, I was trying to get that wire down the inside, it's not gone down the inside. That looks pretty good. Yep, okay. And I'll have a shorter, since I'm putting that at this end, I'll have a shorter brown wire coming out for the, I'll just pull a loop out. So I'll just connect a full length bit of wire on and pull the loop out with the switch. Should do it, get the wire out of the way. The wire is my generic connecting wire. It's the stuff I use all the time. I've provided a link to it before, but it's got 7 strands. I think it's 0.02 millimeter. I'm not sure. I'd have to check that again. It's quite a thin cable, but it's amply rated for this application. And the fuse in the plug, because of course it's the UK, it's a square pin plug at the other end of this. It's a 3 amp fuse, which is fine. This cable is probably rated approximately 1 or 2 amps. I could change the fuse to a 1 amp fuse. They do them, but they're not a standard fuse size. Officially, the only fuse sizes recognised, the plugs are 3 and 13 amp. Right, this is looking good so far. I'm going to go and get some heat shrink. I have a choice. I've got this one which looks just borderline, or this one which actually looks too big. Excellent, a good choice then. We'll go for the slightly bigger one and hope it shrinks down enough. It's much easier than trying to thread on a one that's too small. So I'll just slide that down there. Put that over there. Use the heat gun, which I'm now firing heat into a sort of confined area, so I'll probably end up melting all the plastics. Oh, that's looking pretty good. That's fine. All I really want to do is clamp it onto the sort of like the terminals down there. That's pretty good. That's done the job. It shielded the connections. I'm not too bothered about putting these back in because they're just not needed, so I won't. I don't think it's going to affect the, no, it's not going to affect the clamping of the diffuser. So I'm going to thread these wires down the middle now. This is where they just will consistently not want to go down the middle. I've just suddenly realised that this means the switch is going to be the other end from where I normally have it. But that's okay, I'll soon get used to that. Oh, you know what? These must have a purpose. I reckon these are quite important, so I suppose I better use them then. So I'll pull this out, shove it down the inside like that. I think it just gives extra rigidity in here. Yeah, looks like it's probably important. I'll put them in. Thrust these wires down here, hope they actually go all the way down the inside and don't just snag up on the inside as sometimes happens. And theoretically this end can just get snapped in, which it's just done. I've got the wires hanging out the end. I want to pull a loop out in the brown and I want to solder it in line with that switch. So I could use my long nose pliers for this. The long nose pliers, which are now elusive, there they are. Let's grab the brown wire of the long nose pliers, pull a little bit out, leaving enough at the other end that I can actually connect with. That looks good to me. So I shall cut this, strip it, this should be good actually, because if anything, that area of the where I use the computer, it's always been a bit bright, and this should lower the intensity a bit. Let's see if I can actually get this sleeve off the switches now, switch connections, and also put another bit of sleeving back on afterwards. Shall get that solder off. May have to flow some nice juicy lead-based solder on this just to actually just to make that flow better. It always works better. I can get rid of that module. So let's flow some fresh solder on it, wets it, it just makes it mate better. And also if this is lead-based lead-free solder that's on that already, it means it will just be a bit of a higher temperature to the lead-based solder. I always recommend the lead-based solder. Ignore the people that are saying, it's dangerous, it's poisonous. It's not in the sort of way we're using it. Things get blown out of proportion. You get the sort of people who just always take an extreme stance on things. This heat shrink is what I'm going to use. I'm going to take a little snippet of this, another snippet, just basically to shield these terminals once these are soldered on. Sometimes I wonder, are these videos, when I do something like this, when I don't keep sort of cutting, are they too long? That's your call, if you think they're too long or not. Let's get the heat shrink on over that. That would be a great idea before I solder the connection. That is a textbook error that I've done it in the past. I'll do it again. Everybody does that. Could be worse. MD, who makes off audio connectors and stuff like that, will have been in a situation they've made a connector off lots of footery little terminals, and then once they've done it, they've realised they didn't thread the cap over it, so it suddenly makes it very, well, they basically have to desolder the whole connector again. That is super annoying when that happens. And even veterans of the industry make that mistake still. It's just how it is. It's very easy to do. This wire is somewhat shorter because it's the one that's coming directly from the incoming supply. If I'd been really methodical there, I would have actually poked a tester into the cable and seen what the polarity of those two connections then, because it does look like a fairly keyed connector. But it doesn't really matter. It's not. There's nothing really in this that would pose a hazard if. It's not like there's a fuse in the live in this unit. It's in the plug. So I shall shrink these down. Looks a bit wrinkly, but that's all right. It's fine. Then I shall decide which way do I want that connector. This live wire's tried to sneak up the end. Has it come back out again yet? No, it's not. It's fankling up inside. Right, okay, that's it. So, which way do I want it? If I'm up there, I turn it on by going that. I'll do it that way. Yeah, that looks pretty good. I shall put it in like this. Job done. Excellent. So now I've got my live and neutral out the end that I'm going to cut to the same length, cut down in size a bit. I'm going to want to push this down. There's plenty of room for that, so I'll cut these down. Don't worry, I do use all the little bits. I use them as jumpers for other things. And I'm going to solder these directly onto the input to this power supply here. They're going straight to the bridge rectifier. No fuse or anything, which means that when it fills it will go with a bang. Oh well, that's what happens. So I want to tin these wires. One good thing about long videos is that some of you just want to relax and watch a long video, and the others who don't can skip forward. That's the joy of YouTube. It lets you just skip to wherever you want. I should actually theoretically be zoomed in this, but you know fine well that what would happen, I'd end up going way off short, as I often do when I'm engrossed. So let's reflow these with juicy lead-based solder. Let's crop these wires down just a tiny, tiny bit. Solder that on there. Basically, I've tinned these wires, so I'm just reflowing them. And there. There is another option, but it's going quite extreme. If the current had been too high, if the voltage had been floating up too high on the LED tape, I could theoretically have changed a resistor in here, that little sense resistor on this circuit board. Don't think I'd need it though. This is also going to run a bit cooler than it used to in the past because it's used in a very small area. So now I want to drill a hole in here, but I have to keep in mind that this thing is coming up to about there. Which is actually coming in a bit too far for my liking. Maybe I'll just end up leaving that out. What would happen? Is that just not going to latch? No, it's not going to latch if I leave that out. That's why that's there. That's just a little bit annoying, but not to worry. I shall improvise. I need to put the LED tape up. This is where I could actually mount. Let's stick the LED tape. Let's bias it down to the other end. So let's peel this off, the sticky back. See where this is going to lay initially. It's going to go from there to about there. Okay. Yeah, that area where the wires are coming through is actually right where that little thing is. That's a wee bit annoying, but that's okay. We'll improvise. So I'm going to peel this off. I'm going to make a dog's dinner of sticking it on. I'm going to do my best here, but you just never know. Will it actually even stick? Maybe I should have roughed that plastic up. Acetone's good for that, just creating a sort of rough texture on the plastic. That's looking all right. I'll give it a rub on to see if it can make it stick to any level. Now what I could do here, I could theoretically, oh, you know, that would work really well. If I was to use a pair of snips to just cut those pins off completely, or even hike them out. Can I hike them out? No, I would cut them off. Cut them in as much as possible. I can theoretically run the wires through that out and then fold them back across there. That would work, wouldn't it? So where's my positive? The positive is not where I want it. That's exactly what happens. Perfect. So I'll put a fold in that wire and shove it down the inside. I'm going to bring these through here. This is going to be a disaster. This is going to be a disaster. I'm going to clip this in, then find the wires don't reach. I'll just clip it down enthusiastically with thinking it's going to work. Oh no. And then we'll see if these wires reach. They do. Perfect. So, technically speaking, I should have had a cable here so I could actually demonstrate this. I don't have a cable to power it, but I kind of know it's going to work. So let's flow a bit of fresh solder onto these. The positive is going there. Let's crop these wires down a bit. That would be very professional, wouldn't it, if I made it look like I actually wanted to make a decent job. So let's crop those off. Put that down there. This will also let me see how long it actually took me to do this, because these little tasks, that doesn't seem like they take an awful long time, but that's because you're engrossed in them. And there's nothing quite like being engrossed in a job to make time fly. So let's flow that wire onto there, give it a second to cool, and this wire onto here. Make sure I don't touch myself with the soldering iron. I see I almost did it again. Let's get around here and do this. Yeah, it would have been better if I'd been zoomed in for this, but I wasn't. Not to worry. That looks pretty good. The module is down, tucked about under here. All I need to do theoretically now is clip the cover back on, the diffuser. And that should theoretically be it. Fixed. Turned into an LED light. Of course, if you had a vehicle or an off-grid system, you could actually use this just with a 12-volt supply. You could just convert an existing 240-volt supply with the LED tape. Now I have to pause and roughly wire this up so you can see the result, because you'd have to see the end result, wouldn't you? I can't just leave it hang like that. So just one moment. Okay, I've used a non-compliant electrical connection method involving wires and heat shrink. And let's plug it in. So the switch works. Yes, switch works. Power consumption is 3.7 watts. Power factor is shit, but that's okay. It's very low power anyway. And the illumination level looks pretty good. I'm just going to turn this light off. That's perfect, actually. That's much better because this way it was swamping it out a bit too much. It was a bit too bright before. And now it's not too bright. Well, it is now. So that's ideal. If you notice, the hoppy has just stopped flickering. It's just because it's darker now. The frame rate is the sort of exposure time is longer, and it gets rid of the flicker from the multiplexing. So that's a good result. My light is now fixed, and I'm going to install it and then surf the internet because that sounds like a good idea.